Good morning, my dear students. In our previous video, I discussed about a very important numericals of electric charges and fields based on Coulomb's law. That is, F is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. And in today's class, we are going to discuss a few more important numericals based on electric field. Okay, so as you know, the electric field formula is E is equal to 1 divided by 4 pi epsilon naught Q divided by R square. This Q is charge due to which electric field is created, and this R is distance, okay, between this charge and the charge which is experiencing electric field due to this charge. Okay, for example, this is a charge, let us call it as Q. Okay, if we want to calculate electric field at this point, we are supposed to place a charge, and that charge has to be a very small value. Okay, if I place this charge, okay, this charge can attract this charge or repulse this charge based on the polarity of this charge. If it is positive charge, then it is going to be get repulsed. If it is negative charge, then it is get attracted. Okay, and this distance between these two charges is R. Okay, and this is the formula in order to calculate electric field due to point charge. Okay, so let us begin our numerical session. So this is our first numerical, very famous numerical. See here, 4 charges plus 5 microcoulomb, plus 5 microcoulomb, minus 5 microcoulomb, minus 5 microcoulomb are placed at the corners of A, B, C and D of a square B of side 1 meter. Okay, it means the side of the square is given, it is 1 meter, and 4 charges are placed in the 4 corners of a square. Okay, and calculate the electric field at the center of square. See here, this is a square. Okay, so let us call it as A, B, C, D. A, B, C, D is a square. So charges are placed 5 microcoulomb, 5 microcoulomb, minus 5 microcoulomb and minus 5 microcoulomb. Okay. See, A and B are having 5 and 5 microcoulomb charges, and C and D are having minus 5 and minus 5 microcoulomb charges, and we are asked to calculate the electric field at the center of a square. Okay, and center of the square is intersection of diagonals. So this is intersection and intersection of diagonal, and it is center of the square. Let us call it as O. Okay, and see here, side is given, it is 1 meter. Since it is a square, side is going to be same, and we are supposed to calculate electric field at this point. Okay, and remember, electric field formula is E is equal to 1 divided by 4 pi epsilon naught Q divided by R square. This Q is source charge, and this R is distance between source charge and the point where we are interested to calculate electric field. Okay, it means if we want to calculate electric field at this point due to a charge, we are supposed to know this distance. Okay, if we want to calculate electric field at this point O due to this 5 microcoulomb charge, then we are supposed to know this BO distance. Similarly, CO distance, DO distance, all the distances we are supposed to know. Understood? Okay, and remember, since it is a square, AO is equal to BO is equal to CO is equal to DO. All the distances are same. Okay, so this is all about diagram. So let us begin the solution. Okay, and see here, this distance is how much? 1 meter. Okay, and we want this distance, and remember, if this distance is 1 meter, we shall draw a perpendicular like this, and this is going to be 1 by 2 and this is going to be 1 by 2. Okay, and according to Pythagoras principle, this distance is going to be, AO distance is going to be addition of square of these two, that is let us call it as m. Okay, AO square is equal to MO square plus AM square, and MO square is 1 by 4 because this distance is 1 meter, therefore it is half meter, and 1 by 4, so it is 1 by 2. AO square is equal to, similarly AO is equal to 1 by root 2. And remember, AO is equal to BO is equal to CO is equal to DO is equal to how much? It is 1 by root 2. We know the distance now. Okay, so I will write here again, AO is equal to BO is equal to CO is equal to DO is equal to 1 divided by root 2 meter. Okay, now see here, first we shall calculate. If I place a test charge, a small positive test charge at location O, if I place that charge, small test charge will get repulsed in this direction due to this positive charge. Okay, and that is electric field at O due to A, let us call it as EOA, is equal to 1 divided by 4 pi epsilon naught Q divided by R square is there, and 1 divided by 4 pi epsilon naught is 9 into 10 to the power 9, and Q is there. Q is what? This source charge, that is 5 into 10 to the power minus 6 divided by distance R. R distance means this AO distance. AO is how much? It is 1 divided by root 2. If I square this, then it is going to be 1 divided by 2. Okay, so it is 90 into 10 to the power 9 and minus 6, it is plus 3. Since it is electric field and unit of electric field is F is equal to, E is equal to F divided by Q. E is equal to F divided by Q. Force experienced by unit positive charge at that location is called as electric field. Therefore, it is Newton per Coulomb. This is the unit. Okay, this is first calculation. Second calculation, electric field at O due to B charge. It means electric field at point O due to this 5 microcoulomb which is located at B. Remember, if I place a positive test positive charge Q here, unit positive charge, this 5 microcoulomb will repulse in this direction. Initially, this was the repulsion created on this small Q charge due to this 5 microcoulomb located at A. Okay, and once again 1 divided by 4 pi epsilon naught Q divided by R square. Once again 1 divided by 4 pi epsilon naught is 9 into 10 to the power 9, and Q value is 5 into 10 to the power minus 6. Because microcoulomb is there, we are supposed to convert it into 10 to the power minus 6 because micro means 10 to the power minus 6. And R value means BO distance. Once again BO distance is 1 by root 2. If I square it, then it is going to be square and square root get cancels. What is remaining? 1 by 2 is remaining. Therefore, it is once again 90 into 10 to the power 3 Newton per Coulomb. I will wash it. Similarly, electric field at O due to C charge. It means electric field at this location, this point O, due to this minus 5 microcoulomb charge. Remember, this test charge is positive, and at C location minus 5 microcoulomb is there. Therefore, this minus 5 microcoulomb will attract this test charge in this direction. Initially, E, electric field OA was in this direction, and now electric field at O due to C is also in this direction. Okay, Therefore EOC is equal to once again 1 divided by 4 pi epsilon naught Q divided by R square. 1 by 4 pi epsilon naught value is 9 into 10 to the power 9. Q value is minus 5 microcoulomb is there. No need to write minus. So 5 into 10 to the power minus 6 divided by CO. CO distance is how much? 1 divided by root 2. If I square this, then it is going to be 1 by 2. It is also 90 into 10 to the power 3 Newton per Coulomb. Okay. Similarly, okay, next one, that is electric field at O due to minus 5 microcoulomb located at D. That is 1 divided by 4 pi epsilon naught Q divided by R square. Once again 1 divided by 4 pi epsilon naught is 9 into 10 to the power 9. Q is minus 5 microcoulomb is there. Therefore 5 into 10 to the power minus 6. R square. R square means DO. DO distance is how much? 1 by root 2. Once again it is, if I square this, it is 1 by 2. This is also 90 into 10 to the power 3 Newton per Coulomb. Okay. It means in this direction electric field OB was there. OB. And now once again electric field due to OD is also in this direction only, because this is attraction. Okay, therefore I will write here EOD. Okay, see here EOB and EOD are in this direction. EOA and EOC are in this direction. Okay, and resultant of these two will be in this direction. Okay, so from these we can write it as EOA plus EOC. Since they are acting in same direction, therefore I am adding EOA is how much? 90 into 10 to the power 3 plus 90 into 10 to the power 3 is equal to, it is 2 times 90, therefore it is 180 into 10 to the power 3 Newton per Coulomb. Similarly, EOB and EOD are in same direction. EOB plus EOD, they are 90 into 10 to the power 3 plus 90 into 10 to the power 3 is equal to 180 into 10 to the power 3 Newton per Coulomb. Okay, and see here these two vectors, okay, one is in this direction, another one is in this direction. Let us call it as E1 and it as E2. Now this one is E1 or it is E2 and this one is E1. Okay, and the resultant of these two will be in this direction. This is resultant. Okay, and remember E1 and E2 are having same magnitudes. Okay, if two components are having same magnitude, then resultant can be calculated with the help of this formula. E is equal to 2E cos theta divided by 2, where theta is angle between two components. Okay, and 2E, this E is either E1 or E2 because both are having same magnitude. Therefore it is 180 into 10 to the power 3. And cos theta by 2 is there. See, theta is 90 degree actually, and 90 divided by 2 is 45. Therefore it is cos 45. 2 into 180 is 360 into 10 to the power 3. See here, this E2 and E1, they are having 90 degree actually, and cos 90 divided by 2 is 45, and cos 45 is 1 divided by root 2. Okay, solve this. E is equal to 25.45 into 10 to the power 4 Newton per Coulomb. This is the answer. Okay, so I will write here E is equal to 25.45 into 10 to the power 4 Newton per Coulomb. This is electric field intensity at O. Okay, due to all these four charges. Okay, Okay, you can take a screenshot. Okay, this is our second numerical. Look at the numerical. An electric dipole consists of two charges plus 2 microcoulomb and minus 2 microcoulomb separated by a distance of 1 centimeter. Calculate the electric field intensity at a point on the axial line of dipole at a distance of 10 centimeter from the midpoint of dipole. Point on the axial line of dipole at a distance of 10 centimeter from the midpoint of the dipole. See here, dipole means two equal and opposite charges separated by a finite distance is called as what? Electric dipole. And here two charges they have given, plus 2 microcoulomb and minus 2 microcoulomb charges they have given, and these two charges are separated by 1 centimeter distance. Okay, see here, this is dipole actually. Okay, and one charge is minus 2 microcoulomb, another charge is plus 2 microcoulomb. The direction of dipole moment is always from negative to positive, and the distance between these two is 1 centimeter. Okay, this is not 1 centimeter length actually, this is very large length. Okay, but in the numerical they have given 1 centimeter. This distance is 2L, because dipole moment formula P is equal to Q into 2L is there, where Q is what? Magnitude of either of charge, and 2L is what? Distance between the charges. Therefore, distance between the charges is 1 centimeter they have given. Okay, and the question is, calculate the electric field intensity at a point on the axial line of dipole at a distance of 10 centimeter from the midpoint of dipole. Okay, this is the midpoint. From the midpoint of the dipole, we have to consider 10 centimeter distance. Let us call it as 10 centimeter. Okay, let us call it as A. And A location is what? A location is at a distance of 10 centimeter from the center of the dipole. Okay. And let us begin its solution. As we know, electric field intensity at a point on axial line of dipole, and that is E is equal to 1 divided by 4 pi epsilon naught 2p divided by r cube, where this r distance is what? Distance between center midpoint of the charges, midpoint of the dipole, and point A. Okay, and 2p I can write it as 4 pi epsilon naught 2 p is q into 2l divided by r cube, and 1 divided by 4 pi epsilon naught is 9 into 10 to the power 9. 2 q is, okay, it is actually magnitude of either of the charges, therefore I can write it as 2 into 10 to the power minus 6, and 2L, it is 1 centimeter, 1 into 10 to the power minus 2 meter, divided by r cube is there, and r cube is 10 into 10 to the power minus 2 cube. So 36 into 10 to the power minus 6, 7, 8, and it is 1 divided by 10 to the power minus 1 actually to the power cube. So 36 into 10 to the power 1 divided by 10 to the power minus 1 is there, therefore it is 10 to the power minus 3, and 36 into 10 to the power plus 4 Newton per coulomb. It means at this point A, the total electric field intensity due to this plus 2 microcoulomb and this minus 2 microcoulomb charge is going to be 36 into 10 to the power 4 Newton per coulomb. Okay, this is our next numerical. 2 point charges of plus 25 microcoulomb and minus 9 microcoulomb are placed 8 centimeter apart in air. Determine the position of the point at which the resultant electric field is 0. It's a very simple numerical actually. See here, two charges they have given. One charge is plus 25 microcoulomb and other charge is minus 9 microcoulomb. Okay, are placed 8 centimeter apart. The distance between these two charges is 8 centimeter in air. Determine the position of the point at which the resultant electric field is 0. Let us consider one point here at a distance x. Let us call it as x distance because we don't know the distance actually. And this x we have taken from minus 9 microcoulomb. Remember this point. Okay, otherwise we can choose any one point in between these two charges also. Okay, and let us call it as point O. At point O, due to plus 25 microcoulomb and due to minus 9 microcoulomb, the total electric field strength is going to be 0. Okay, it means if I place a test charge here plus Q, this 25 microcoulomb will repulse and minus 9 microcoulomb will attract. Okay, you can observe here two equal and opposite forces are there. I mean then and then only the net electric field at this point is going to be 0. Okay, so let us begin our solution. Okay, let us call it as point A, this as point B and that point as O. Okay, electric field intensity at O due to A, it is EOA is equal to 1 divided by 4 pi epsilon naught Q. Q is 25 microcoulomb. It is 25 into 10 to the power minus 6 divided by R square. R square means distance, 25 distance between A and O. A and O is 8 centimeter plus x centimeter, that is 8 plus x square. Okay, is equal to 9 into 10 to the power 9, 25 into 10 to the power minus 6 divided by 8 plus x square. Okay, and the electric field intensity at O due to B, that is EOB is equal to 1 divided by 4 pi epsilon naught, this distance, it is how much? X, and the charge is how much? 9. 9 into 10 to the power minus 6 divided by x square. Okay, or 9 into 10 to the power 9, 9 into 10 to the power 9 divided by x square. Okay, if electric field intensity at this point has to be 0, then electric field at O due to A and electric field at O due to B, these two must be equal. Okay, therefore electric field at O due to A is equal to electric field at O due to B. Then and then only at point O the electric field intensity is going to be 0. And EOA, it is 9 into 10 to the power 9, 25 into 10 to the power minus 6 divided by 8 plus x square is equal to 9 into 10 to the power 9, 9 into 10 to the power 9 divided by x square. So 9 into 10 to the power 9, 9 into 10 to the power 9 is cancelled. Sorry, this is not 10 to the power 9, it is 10 to the power minus 6. So 10 to the power minus 6, 10 to the power minus 6 is cancelled. So 25 divided by x square, sorry, 8 plus x square is equal to 9 divided by x square. Okay, and I can write it as 5 divided by 8 plus x is equal to 3 divided by x. So 5x is equal to 8 plus 24 plus 3x, and 5x minus 3x is 2x is equal to 24, and x is equal to 12 centimeter. And from B point at a distance of 12 centimeter, the electric field intensity is going to be 0. Remember, this distance is 12 centimeter. Okay. And from A point, the total distance is going to be 8 plus 12, that is 20 centimeter. It means electric field intensity at a point O is going to be 0 at a distance of 20 centimeter from A, 12 centimeter from B. Understood? Okay, this is our next numerical. Let us have a look. The electric field components in figure shown below are Ex is equal to alpha x to the power 1 by 2, Ey Ez is equal to 0, in which alpha is equal to 800 Newton per Coulomb meter to the power 1 by 2. Calculate flux through cube, okay, and net charge within the cube. Assume that A is equal to 0.1 meter. Okay, side they have given actually A is equal to 0.1 meter. Okay, you can observe this cube very carefully. Okay, see, this cube has actually 6 faces. Okay, and in those 6 faces, only 2 faces, shaded faces, are linked with electric field lines. Okay, electric field lines are linking with only this face and this face, shaded faces only. For example, if I consider this as a square, the electric field lines are traveling this way. Okay, in this way, and electric field lines will link with this face and this face. Okay, but these 2 faces and top face and bottom face, they are not linked with any electric field line. Okay, or you can treat this way also. If this is the face surface, then this is the direction of area vector, and these are the electric field lines. It means the angle between area vector and electric field lines is how much? It is 90 degree. Therefore flux linkage is 0. For below surface, bottom surface, this is the direction of area vector and these are the electric field lines. The angle between these two is once again 90 degree. Therefore flux linkage is 0. If I consider this face, this is the direction of area vector, because the area vector is always perpendicular to the surface, and this is area vector, these are field lines, once again 90 degree. Flux linkage is 0. For this surface also, the area vector is area vector and electric field lines, they are at 90 degree. Therefore flux linkage is how much? 0 degree. It means the flux is going to obtained only with the help of these 2 surfaces, because the angle at this point, it is 180 degree. You can observe electric field line is in this way and area vector is perpendicular. Okay, it means for this surface, area vector is in this direction and electric field lines are traveling this way. It means the angle between these 2 is how much? It is 180 degree. And at this point, electric field and area vector are having 0 degree. Therefore we are going to get flux. Okay, so no need to calculate for these surfaces, because the electric flux is how much? It is 0. And let us begin with solution. So we shall calculate flux through linked with only these 2 shaded faces actually. Let us call it as first phase. This is first one and this one is second phase. For first phase, okay, and a flux formula is what? Pi is equal to E into ds. Okay, first we are supposed to know what is E, okay, and then we can calculate flux. So first we shall calculate electric field. Electric field E is equal to, they have given alpha x to the power 1 by 2. Okay, alpha x value we know it is A, okay, to the power 1 by 2. And now electric flux, let us call it as pi 1 is equal to E into ds, and E value we know it is alpha A to the power 1 by 2, and ds is what? Surface, so it is first phase, surface of first phase, it is A into A, that is A square, and the angle between these 2 is how much? It is 180 degree. cos 180 degree. You can observe here, this is electric field and this is area vector. These two are perpendicular, opposite to each other, therefore angle is 180 degree. Therefore it is alpha a to the power 1 by 2 a square, it is a to the power 5 by 2, and cos 180 is minus 1, or I can write it as minus alpha a to the power 5 by 2. This is flux linked with first phase. Okay, and for second phase, Ex is equal to, once again, alpha x to the power 1 by 2, and alpha x value for this case it is a plus a, it is 2a, so it is 2a to the power 1 by 2. Therefore flux linked with second phase is equal to E into ds, and E value it is alpha 2a to the power 1 by 2, and ds value, once again ds is how much, it is a into a, this is a into a, that is a square, and cos theta value is how much, for this actually this is the direction of area vector and this is the direction of electric field, both are in same line, therefore cos theta is cos 0 and cos 0 is 1, therefore I can write it as flux linked with second phase is equal to alpha 2 to the power 1 by 2, and a to the power 1 by 2 a square, it is a to the power 5 by 2, and cos 0 is 1. Okay, and now total flux pi is equal to pi 1 plus pi 2, and pi is equal to, pi 1 is how much, it is minus alpha a to the power 5 by 2, and pi 2 is plus alpha 2 to the power 1 by 2 is there, therefore I can write it as root 2, and a to the power 5 by 2, and in this what is common, alpha is common, a to the power 5 by 2 is common, and inside the bracket root 2 minus 1. This is total flux. Okay, but they have given certain values here, they have given alpha value and a value is how much, it is 0.1. I can substitute here, pi is equal to alpha value is 500 into a value is 0.1 to the power 5 by 2 and root 2 minus 1. Okay, so it is, when you solve this, it is going to be 1.05 Newton meter square per coulomb. This is electric flux linked with these two phases, okay, due to the charge inside the cube. And the second calculation is there, this was first calculation, flux through cube, okay, you can note down. For second calculation, I will wash this. That is second calculation, charge inside cube. For that we can make use of Gauss law, that is flux linked to a closed surface is equal to Q divided by epsilon naught, and Q is equal to pi into epsilon naught. Pi value is 1.05 and epsilon naught value is 8.854 into 10 to the power minus 12. Therefore Q value is equal to 9.27 into 10 to the power minus 12 coulomb. Okay, so this was very important numerical, note down. Okay, this is our next numerical. See here, a point charge plus 100 nanocoulomb is at a distance of 2 mm directly above the center of a square of side 5 centimeter of a cube as shown in figure. What is the magnitude of the flux through the square? Okay, see here, one square is there. like this. This is a cube. Okay, for this surface they have placed a 100 nanocoulomb charge. Okay, and this cube has a side how much? 5 centimeter, and it is 5 centimeter. Okay, and according to Gauss theorem, flux linked, okay, with any closed surface is equal to Q divided by epsilon naught. Okay, actually for the closed surface, for an entire cube, Q divided by epsilon naught is there, but they have asked for only one surface. What is the magnitude of flux through the square? For this surface only they have asked. Okay, therefore 6 faces are there. Therefore we can calculate. For one surface it is 1 divided by 6, Q divided by epsilon naught. So 1 divided by 6, Q is how much? 100. Nanocoulomb is there, therefore it is 100 into 10 to the power minus 9, and epsilon naught value is 8.854 into 10 to the power minus 12. Therefore it is 10 to the power minus 9, 10 to the power minus 12 is there, therefore 10 to the power 3 divided by, and 100 is there, therefore it is 10 to the power 5 divided by, approximately it is 54 into 10 to the power 1. So it is 1 by 6, 10 to the power 2 and 10 to the power minus 9. It is 10 to the power minus 7 divided by 8.854 into 10 to the power minus 12. Therefore, flux is equal to 1.22 into 10 to the power 3 Newton meter square per coulomb approximately. Okay, so this is flux linked with only one surface, one phase. Okay, and for a 6 phase it is the formula pi is equal to Q divided by epsilon. This is for the entire cube, and this is for only one surface, one phase. So it is 1 by 6, 100 is there, 100 and 10 to the power minus 9, it is 10 to the power 2 minus 9, it is minus 7 divided by 8.854 into 10 to the power minus 12. So it is pi is equal to 1.88 into 10 to the power 3 Newton meter square per coulomb. This is flux linked with only one phase. Okay, and for a 6 phase it is pi is equal to Q divided by epsilon. This is for Q, and this is for only one phase, because they have asked what is the magnitude of the flux through this. Okay, this is our next numerical. See here, an electric dipole consists of two opposite charges of magnitude 1 microcoulomb each and is separated by a distance of 2 centimeter. Okay, dipole is placed in an electric field of 5 into 10 to the power 5 Newton per coulomb. Find the maximum torque on dipole. See here, this is electric field. Electric field strength is been given actually, and this is dipole. This is minus Q, this is plus Q. Okay, and see, for a solution, torque formula is, we know, torque experienced by dipole kept in uniform electric field, because you know this minus Q will get attracted by electric field, and this plus Q is get repulsed by electric field. Okay, therefore these two forces, F is equal to QE and F is equal to QE, these two forces, okay, couple of force constitute torque, and therefore this dipole experience a rotation. Okay, because all the positive charges located here and all the negative charges located here, these positive charges get repelled by these positive charges, and this negative charge get attracted by positive charge, okay, and this positive charge also get attracted by these negative charge. Therefore a couple of force constitute torque, and torque formula is tau is equal to P cross E, where P is dipole moment and E is what? Electric field intensity, okay, and since cross product is there, therefore I can write it as PE cos theta, sorry, PE sin theta. Cross product of two vectors always results a vector again, okay, and see, if theta is equal to 90 degree, then and then only torque is going to be max, for maximum torque, okay, and tau is equal to P. P value is what? Q into 2L, because dipole moment is equal to what? Dipole moment is equal to Q into 2L. Q is magnitude of either of charge and 2L is separation between the charge, therefore Q into 2L, and E electric field, therefore Q value we know it is given. How much is this? This is 2 centimeter. Electric dipole consists of charges 1 microcoulomb, okay, so it is 1 into 10 to the power minus 6, and 2L, distance between these two is how much? 2 centimeter, so it is 2 into 10 to the power minus 2, and the electric field is also given, it is 5 into 10 to the power 5, okay, so it is 10 to the power minus 6, 10 to the power minus 2, 10 to the power minus 4, minus 8, and it is 10 to the power 3, so 10 into 10 to the power minus 3, okay, or 10 to the power minus 2, so it is Newton meter. So maximum torque experienced by the dipole is how much? 10 to the power minus 2 Newton meter. Look, a thin walled copper pipe 5 meter long and 2 centimeter in diameter carries a net charge of 10 microcoulomb distributed uniformly, okay. What is the electric field at 10 centimeter from the pipe axis? See here, a thin walled copper pipe is there, this is copper wire, okay, and this is axis of the pipe, and the length of the wire is given actually, length of the copper pipe is given, that is L is equal to 5 meter, okay, and 2 centimeter in diameter, so diameter is also given, diameter is equal to 2 centimeter, or radius is going to be 1 into 10 to the power minus, okay, radius is going to be 1 into 10 to the power minus 2 meter, okay, and charges are distributed uniformly, it means charges are like this. This is linear charge distribution. For a linear charge distribution we have defined one term, that is lambda. Lambda is what? Number of charges per unit length, okay, therefore the total number of charges is equal to Q is equal to lambda into L, where lambda is equal to what? Q divided by L. Q is number of charges, it is given, how many charges is given? It is 10 microcoulomb, and length is given, it is 5 meter, okay, and now the formula for such type of distribution we have already calculated, that is E is equal to lambda divided by 2 pi epsilon naught into R, okay, and in place of lambda I can write Q divided by L, therefore Q divided by L, and it is 2 pi epsilon naught R, Q divided by L, okay, and what is this R? R is distance from the axis, okay, at which we are supposed to find out electric field. In this situation they have given 10 centimeter. See here, what is the electric field at 10 centimeter from the pipe axis? This is axis of the pipe, and this is at a distance 10 centimeter from the pipe axis, okay. Q is how much? It is 10 to the power 10 into 10 to the power minus 6 divided by 2, pi is 3.14 into epsilon naught is 8.854 into r is how much? 10 centimeter. Therefore it is 10 into 10 to the power minus 6, sorry, minus 2. 10 centimeter is there. Therefore L is length is 5 meter. So it is 10 to the power minus 5 divided by, okay, 10 is cancelled here, and 10 to the power minus 2 is there. 5 2s are 10. Therefore 10 into 3.14 into 8.854 into 10 to the power minus 2. 5 2s are 10. Therefore the final answer will be 3.59 into 10 to the power 5 Newton per coulomb. So this is electric field at a point, okay, at a distance of 10 centimeter from the pipe axis.